spherical polar coordinates. Spherical polar coordinates are a system of curvilinear coordinates that are natural for describing positions on a sphere or with spherical symmetry. And we find extensive use of this in physics, for example, while solving the Schrödinger equation for hydrogen atom or say electric potential of a sphere. SPC represent a point P in space by the ordered triplets r, theta and phi, where r is the length of the vector from origin, theta is the polar or zenith angle measured from positive z-axis to the vector r, and phi is the azimuthal angle measured from x-axis to the projection of r onto the xy plane. So SPC locate points in space with two angles theta phi and one distance r, with r always positive, theta running from 0 to pi and phi running from 0 to 2 pi. Let's see the relation between r theta phi and xy set. As you can see, the component of r along z-axis is r cos theta here. Now the component of r along the xy plane has a length r sin theta. Therefore, resolving r sin theta along phi gives x component r sin theta cos phi and y component r sin theta sin phi. The inverse transformation equations can also be obtained with r is equal to root of x square plus y square plus z square, which is obtained by squaring and adding the first three equations. Then theta is tan inverse of root of x square plus y square by z, and phi is tan inverse y by x. Now let's see the constant coordinate equations in spherical polar coordinate. So first, when r is a constant with theta and phi varying, it describes a sphere with radius r centered at the origin. Hence r is always positive. Now theta is a constant with r and phi varying. It describes a single cone whose vertex lies at the origin and whose axis lies along the z-axis. Now this idea can be broadened to include, say that xy plane will be obtained with theta equal to pi by 2, and when theta becomes greater than pi by 2, the cone opens downward. Now phi being a constant, this equation describes a plane that contain the z-axis and make an angle phi with the positive x-axis. So we find that the constant coordinate equations in spherical polar coordinate yield spheres, single cone and half planes. So that was a brief introduction to spherical polar coordinate and constant coordinate equations in spherical polar coordinates. Thank you.